Hey, so this is our last video of section 3.5 and also our last video of chapter 3 altogether. In this video, we're going to be talking about reflections, which is our final transformation of functions that we'll be studying. And these show up again and again. So the first reflection we're going to look at is reflection across the y-axis. And so we know what the graph of the square root of x looks like. Know that if we draw an axis, then the square root of x looks something like this, where value like 4 gets mapped to 2. So you just plug in the number, take the square root. That's good and simple. So we'll call that h of x equals the square root of x. This example is asking us to graph the negative square root of x. And we can kind of think about that as we're just going to reverse the sign of the graph. If we plug in -4, those two negatives cancel out and actually give us a positive. For instance, we plug in -4, that becomes -4, which is +4. And we take the square root of that and we get 2. So for -4, we get 2. And maybe we should think about the domain of this function as well. So maybe pause the video and think about what the domain has to be. Okay. So hopefully you came up with that the domain is going to be -∞ to 0. Because if we plug in any positive numbers, we're going to be taking the square root of a negative, which for now we're saying we can't do. But if we plug in any negative number, that negative gets flipped to a positive and becomes a positive. And so as a result, our graph really just looks like it's flipped across the origin like this. Because we can look at f of something like -4, and that's the square root of -4, which is just the square root of 4, which is 2. And that's all there is to it. And so it turns out that whenever your x value just has the sign swapped, the graph is just reflected across the x-axis. Now, what if we have the negative sign on the outside of the graph instead of, on the outside of the function instead of in with the argument of the function? So we have the negative square root of x instead of the square root of -x. So we'll start again with just the graph of the square root of x. So again, this can be h of x equals the square root of x. And now think about what happens when we instead do the negative square root of x. Pause the video and make a conjecture about what you think is going to happen. Okay, so maybe you came up with that if you, again, we look at 4 and say we get 2 out of it. So that would be 4, 2. And of course, this isn't drawn to scale, I'm sorry. Then for our function g of x, we get that g of 4 equals negative square root of 4, which is -2. So for g of x, we're actually down here at -2. And maybe we can see that any number we plug in, we're actually just going to get its negative out for the y value. So our graph ends up looking something like this green line. And so we get a reflection across the x-axis. And so in general, we have two types. We have reflect across the y-axis. And so that would be sending f of x. We would have f of negative x is the reflection of f across the y-axis. And to reflect across the x-axis, we just do negative f of x. And if we remember with symmetry, we had one final type of symmetry, and that was symmetry about the origin, pseudo. And maybe you can make a conjecture about what that would look like. Turns out that this one is actually minus f of minus x. And I think it'd be a good exercise to reason through why this is true. And as a hint, we're going to want to combine the intuition of reflecting across the y-axis and reflecting across the x-axis. All right, happy graphing.